Good evening, everybody. Thank you for joining. Sunil here. Can you hear me? Please confirm in the chat box. Thank you, Sai. Thank you. Thank you for your responses. We have started Kubernetes in the last session. We have learned how to create a pod. We have experienced how can we connect to create a cluster. We also have learned how can we connect to that particular cluster. Let's do it again. Cloud.google.com. Creating cluster will take 2 minutes. Connect to console. Navigation, Kubernetes engine, go to clusters. Go ahead and create a cluster. Go for GK standard. This is the name of the cluster which I want to create and proceed with create. Let's wait for the cluster to get created. Can you hear me? Hello? Yes, okay. Azam. Good evening, Azam. Yeah.
Good evening, sir. Hi, sir. I think it's cold again.
Yeah. Sorry, Azam, I cannot hear you. What did you say?
Sir, I have a doubt. Like in a single node, we can have multiple pods, right?
In single node, we can have multiple pods. Yes, you are right.
Suppose there is two pod. One is database and one is apps.
Okay.
Right. So is pod ephemeral or can die?
Is pod?
Ephemeral. Like in container, we had container ephemeral. Container or ephemeral, right?
Okay.
So pod is also ephemeral.
Pod is also ephemeral. Okay.
Oh,
Pod is
yes.
also ephemeral. Man, in such case, Azam, I already have given clarity. When containers are ephemeral, where exactly it is used? Okay, so why we go for creating load balancer?
Yes, sir. Sir,
Isn't it?
I have doubt for IP address, and suppose I have a database and one app server. In a single node, there is two clusters, right?
Okay.
One
In single,
database.
not clusters, two nodes,
Two,
two pods.
in single node, two pods, right? So how communication will be happening between them? Suppose if communication is established and then one port goes down, then how same IP or same DNS name will be allocated to that pod?
You have to wait, Azam. Okay.
Okay, sir.
Let's wait for the coming concepts.
And same about data, sir.
Yeah, you have to wait.
Thank
So
you.
there's no concept of going down specifically in case of when you're going for Kubernetes engine, because we know the Kubernetes master as a provided is the form of a service, isn't it, Azam?
Yes, sir.
There is no concept of downtime. That is just sure. Okay.
Yes, sir.
Yeah. Let's wait for the cluster to get created. Anuj, in the last session, we have learned how to create a first pod, isn't it? We have learned how to create a pod. And we have done it using the command.
Right, kubectl.
And then we also know how to see the list of all the pods. Kubectl get pods will show you list of all the pods. Okay.
Right, right,
Okay. And if you don't want a pod, you can delete a pod, isn't it?
right, right.
Okay. Let's quickly continue. So the cluster is ready. Yes, perfect.
Right.
Connect to cluster. Run in Cloud Shell. None. You're getting a background noise, Anuj. Are you traveling?
No, let me switch off the fan. Is it okay now?
Yeah, it is okay.
Thank you.
Okay. When I run this statement, what happens? The pod gets created.
Created.
Agree? Name of
Right.
the pod, web server.
Web server and
And
container is
inside the
Tomcat.
pod container will be Tomcat. Yes.
Right.
Done. Now, how to see list of all the pods?
kubectl
CTL get pods.
get pods.
Fine. There's one pod.
Right.
This is a Kubernetes cluster of how many nodes?
3 nodes.
3 nodes. Sure. Isn't it? We have 3 nodes.
Yep, 3 nodes.
How to see the list of all the nodes?
kubectl get nodes.
Now, as per the architecture, the pod runs on Kubernetes master or node?
Pods runs on nodes.
Sure.
Yep.
Now there are 3 nodes, right?
Right.
This particular pod is running on which node? That's my question. If you want to know the pod is running on which node, okay. To know in which node the pod is running, kubectl get pods -o wide stands for, it's all frequently called as wide output. Okay.
Okay. Detail
This is all
output.
is called as wide output. Get pods will show you. Get pods will only show you the pod name and status
Right.
of the pod and age of the pod. Whereas a wide output will give you more information about the pod.
Detail.
Okay. So in detail information about the pod. So I want to know more information. In fact, I want to know finally in which pod that is running. It's wide output. You can see the pod is running on a specific node ending with 155Z. So can you see this 155Z? Yes.
Right.
So that's running on first node. So like this, you can also know, not just know list of all the pods, you can also know on which node the pod is running by going for wide output. Okay.
Right.
Okay. I want to delete this particular pod. That's fine. Okay. Now, but the right way of creating the infrastructure is by using the definition file. I hope you look at the diagram.
Right. YML.
By ML files. We, as a DevOps engineer, you whatever you want to create, whether it is pod or any other objects, you have to provide your request in the form of a YAML file.
YAML.
Let us learn how can we create a YAML file and how can we run that particular YAML file so that you can create the required pods. Okay.
Okay.
Kubernetes performs container orchestration using definition files. Definition files are called as nothing but called as YAML files.
Okay.
Whenever you're creating a YAML file, the YAML file should have 4 elements. The YAML file, let's call it a definition file, should have 4 elements.
Okay.
API version, kind, metadata, specification. Clear, Anuj?
Okay.
The YAML file should have how many elements? 4 elements.
4 elements.
Let's discuss about the first version, API version. Depending upon the Kubernetes object, can you give me one example of a Kubernetes object? One
Pod.
example of a Kubernetes object is pod.
Pod.
Similar to pods, you can see here, Kubernetes uses various objects. One object, what we know is pod. Similar
Right.
to pod, we can create any other objects like service object, namespace, secrets, replication sets, deployment object. These are other objects what Kubernetes can create.
Right.
So when you're creating a YAML file, your requirement can be creating a pod, your requirement can be creating service object, your requirement can be replication set, or your requirement can be deployment, whatever it is. Finally, you'll create you need a YAML file. You have to write that information in the YAML file. That YAML file should have 4 top level elements. I'm discussing about the first top level element called API version. Depending upon the Kubernetes object you want to create, whether you want to create a pod or you want to create a service object, you want to create a replication controller, you want to create a deployment object, there is a corresponding code library which you should refer to. That means API version refers to code library. If you're creating a pod, you have to use API version v1. If you want to create service object, you have to use API version v1,
V2.
namespace v1, not v2, v1.
V1.
Secrets
Okay.
v1. So for the majority of the API versions are v1. Only for replication sets and deployment object, API version you have to mention it as app/v1. That is the libraries which you have to refer to corresponding based on the object which you want to create. Okay.
Okay.
Next, kind. Kind refers to what kind of object you are creating. If you want to create a pod, you have to write it as pod. If you want to create deployment object, you have to mention kind as. The kind is refers to what kind of object.
Object.
Metadata is more information about the object. When you are creating a pod, in the metadata, you should mention the name of the pod. Are you understanding?
Yeah.
If you're creating service object, metadata is all about, you have to provide the name. Metadata is all about additional information about the object which you're creating. Specification is final. Technically, what the pod contains? Container. In the specification section, you have to mention the container in details like what image you are using and all those details.
Okay.
So API, whenever you're creating, whenever you are or when you're performing container orchestration, whatever you want to create, you have to write a YAML file, and that YAML file should have 4 elements. Remember, okay?
Okay.
Let's experience the first definition.
But we can do it with command as well, right?
You can do it as command, but this is the right approach. Okay.
Okay.
Find refers to what kind of object you want to create, whether it is a pod or replication set or etc. Metadata is about additional information about the metadata, additional information about the object. Specification is all about, finally, you need to mention the container information in the specification regarding what environment, where, what image you are using. That use image is having environment variables. Are you performing port mapping? All this you have to define that. Okay.
Define.
So let's proceed. So I want to create all the definition files in a directory. So I create a directory called demo files. I want to place it everything in one directory.
So Sunil, the infrastructure which we have created, this could also be done via this kind of file, right? In the console itself.
The infrastructure?
The infrastructure, the cluster which we have created 3 node. I hope we can also write a code in our laptop and just go and upload it over there and get it created.
You can also do that. Okay. But in Google, in cloud environment, you have corresponding services, right? So which helps you to create the infrastructure. I'm creating a directory called demo files. Okay. I enter into that particular directory. So whatever the definition files, I create this in this particular directory. So that is the name of the directory is demo files. Okay. Fine.
Right. So currently we are on Cloud Shell. Okay.
Yes.
Not on Node.
Cloud Shell is nothing but editor.
Correct. Correct.
There is no concept of connecting to node. I already have mentioned.
Got it. Got it. Right.
We are connecting to cluster.
Cluster.
That's it. Create a pod definition file to start Nginx pod. Okay. I want to name the pod as Nginx-pod. Okay. I want to name the container as app server. So in the pod, finally you have a container. So you need to name the pod. You need to name the container. Okay. Every pod should have a name. Every container should also have a name. Okay.
Name.
Now, first point, every definition should have 4 top level elements, as we know. API version, kind, metadata, specification. These are the 4 top level elements. Now look at the 4 top level elements first. Before understanding the definition file, let's look at the top level elements. Anuj, can you see API version?
Yeah, right. API
Can you
version
see
V1.
kind?
Yep.
Next is metadata. You have
Metadata.
metadata and then specification section. Now tell me your definition file is having all the elements?
Right.
4 elements. So it should be
4
4
elements.
Okay, next. API version refers to libraries. When you are creating a pod, your API version should be V1. Okay, look at the theory. When you are creating a pod, the API version should be V1. Agree?
Right.
So that's the reason I'm writing API version as.
Right. It tells where to go and
which libraries it should
fetch.
refer to.
Fetch. Right.
Yes.
Got it.
Okay. Next, kind. What kind of object you are creating using this definition file? You have to clearly
Pod.
mention that I want to create a pod. Yes. Metadata. You need to provide name to the pod. Okay. When you're creating a pod, you have to provide more information about the pod that you write it in the metadata element. Name, I'm writing it as Nginx pod. Instead of Nginx, can I write name as pod1? Anuj?
Yeah, we can.
Can I write my pod? Pod name can be anything.
Anything.
Okay. Next. In the metadata, there is something called labels also. We provide in the labels, you can see we provide the information in key value pairs. Okay. It can be anything other Sunil. Okay. Or you can see client as PayPal, whatever it is. Okay. So labels is for more information about the pod. And it can be both are user defined, both key and value are user defined. I am creating a pod. So that is the reason. If anybody looks at the definition file, you want to know who has written the file. Isn't it Anuj? So you can mention it, label as Sunil. So that is reference that I have created a file. What type of Nginx is a reverse proxy server? So I'm writing it as reverse proxy. That's it. There's no importance for this. Even though you don't write it, that does not make a problem. But you can have labels which provides more information about the pod. Okay.
Right.
Clear.
Right.
The final section, specification section. Under containers, what is the name? What is this app server name of the container?
Yep.
Okay, in the containers specification section, you should name the container, and the image what you are using is Nginx. That's it. Okay. So like this, it's not just
Sunil,
writing.
one thing is this a case sensitive to capital and small?
Yes, case sensitive.
Okay.
Very important. Okay. And spacing is very important, as you know. The YAML headaches are there. Okay.
I hope we do have an option to verify our syntax over here.
Yeah. You can verify it. Okay, so let's go ahead and create the
got it.
definition file.
So Nginx pod is pod name, right? And app server is containers.
App server, yes, you are right. As app server is the name of the container, and this is name of the pod. Yes, you are right. Yes, Balaji.
Yeah, hello, Sunil.
Yeah, Balaji.
A small doubt. We had not mentioned labels, right? So
you have mentioned it, labels.
Oh, inside labels we have author and type.
These are labels.
Okay. I was just confused with the space.
Okay.
I missed. Okay.
Now you got it.
Yeah, got it.
Okay. Okay. So Balaji, let's go ahead and create a pod. Let's not create a pod. We are creating a definition file. I have created a directory. So using the VI editor, I open a file. Go to insert mode.
Sunil, the last one, Nginx. I hope this is a Docker image name, right?
Yeah, you are right. Docker image name. You are right. Okay. So look, there's some indentation problem I'm experiencing when I'm going for a VI editor. So okay. What I'll do, I create a file using cat command. Okay. Okay, sorry. Cat greater than. Creating a file. Copy. Paste. Okay, Anuj. Escape.
Right.
Sorry, not escape. Colon. Control D, sorry. Okay. Control D to come out of the cat command file. The file has been
Right.
created. You can see the file has been created. Okay. If you want to see the information in the file, you know it, pod definition file, you can see the information present in the file. Okay. Next thing what we should to do, you should run the definition file, is it?
Right. But can we verify the syntax?
These are syntax already verified on this. Okay. So we don't need to do that. Okay.
I just
So-
want to check an opportunity if we can do it.
So I am creating a file. How to run the file? Create -f and mention the file name, pod, whatever the file name. Okay. So this is a kubectl command to run the command definition file. Kubectl create -f, the pod definition file. When you run this, what will happen? The result, Anuj?
It will run and create the pod.
Pod.
Right.
Yes, you're right. Before running kubectl get pods, there's only one pod, I think. So this is that we have
Right.
created a pod using the command.
Command.
Pod created. Okay. Yes, perfect. How to see list of all the pods? Same command. Kubectl get pods. Now you can see
Get
two
pods.
pods. The Nginx pod
Right.
is running. Okay. Yes. So this is how whatever the requirement you have to write it in the form of a definition file. Okay.
Definition.
Now, and I want to know in which pod, in which node that pod is running. You know it. It's a wide output.
So there is no concept of port mapping and all here.
We'll see it soon. Yes, we have it.
Okay.
So here you can see the Nginx pod is running on which particular node. In fact, here both are node pods are running on the same node, 155Z. Okay. So like this, you can know in which pod it is running.
But we don't have control. It will automatically
No.
decide
You
it.
cannot select the pod. There's not even in Swarm also. Just nothing is under control. Okay.
Got
Next,
it.
how to delete the pod?
Same command. We need to kubectl
You have to delete the file.
file.
If you just delete the pod, delete pod name. If you delete the pod, controller manager makes sure that the actual state is the desired state. The desired state is definition file. Actual state there is no pod, so automatically a new pod gets created.
Okay.
Okay, because this is the
Got it.
desired state, right? You have defined your desired state. And if the actual state, if you delete the pod, then actual state is not equal to desired state. Again, what happens? It triggers a new pod gets created. So, in case if you want to delete the pod, you have to remove the definition file altogether
So
from the.
that means we cannot delete a pod with command line.
No, we have to enhance handle from the definition files. Okay, everything should be handled from the definition files.
So it doesn't matter where we create a pod with a definition file or a command line.
If it is a command line, there's nothing called reference, isn't it? The data is
Right.
now stored. So even though you delete it, it not recreate it. Okay. Whereas this is the definition file. So you have clearly informed that this is my requirement. So it always makes sure that the current state of the cluster is matching to your requirements.
So that is why it is not recommended to create it with a command line.
Well, I'm a command line. You cannot use it for reference also. Okay. Okay.
Got it.
Yes.
Got it. So you can create a pod, but the purpose will not be solved.
Solved. That will never done in the real time. It always happens using.
Can we experience it? Can you delete with command line and check it out? It will
Okay.
automatically
So
create.
for example, what is the command? to delete?
Kubectl get a simple kubectl delete.
What is the pod name?
And that's app server.
Nginx -pod.
No, I'm sorry, Nginx -. Yes.
Before deleting, you can see right now it is, you can clearly see. Two pods. Now I'm deleting one pod, sorry.
Right.
I'm deleting
One pod.
one pod.
Pod deleted. It's doing something. It will recreate, I hope.
That's right. You have to wait. Let's wait. Let's wait. Let's have the definition file and let's continue. Okay, we'll not remove the definition file. Okay, so let's continue.
Yeah, please.
Okay.
So
Let's
that
move
means
on.
we have to make sure that our definition file is secure. Nobody should be able to delete it, and we have to
Yeah,
keep
yeah.
it safe.
Yes, yes. Okay, so let's
So we
wait.
have to wait. Please proceed further.
Let's wait. Okay, let's move on to next concept called replication controller. Okay. So second type of object what we are learning is replication controller. Maheshwara.
Actually, in that you are creating the pod definition in the YAML, you are not closing that with a double quote.
Those are optional. Okay, it's not mandatory. Okay, 3 hyphens and 3 dots are optional.
Okay.
Maheshwara.
Second thing, what you are trying to say, I just missed it actually. You are trying to.
So what I mean to
delete-
say, if you want to delete, if we have deleted a pod, right?
Okay, delete
We
that
have
say
deleted.
pod.
We have deleted the pod.
Right.
Now, as per my understanding, it should recreate it. Okay,
Why?
automatically,
Why, Sunil?
because the controller manager status. What the control manager says, Maheshwara, control manager is actual state is equal to always the actual state of the cluster should be equal to the desired state.
Besides,
What you have clearly mentioned your desired state in the YAML file that you want one pod, and that
okay,
pod is now available. Now, when you remove the pod, automatically control manager makes sure the new pod should be created. Okay, so always the new pods will be created. Okay,
okay.
why the new pod is not getting created? I have to check. Okay, so let's move on to next object called replication controller. Let's move on to next object called replication controller. Okay, so we have learned first object called pod. Now we are learning second object called replication controller. Please mute Balaji. I'm muting you. Okay. Replication controller is a high-level object used for handling multiple replicas. Anuj, we have expressed the term called replicas in Docker Swarm, where you want multiple containers.
Right.
Here it is called as multiple pods. Okay, where we can, the advantage what you can do is you can perform load balancing and scaling. The replication controller uses keywords like replicas, templates in the specification section. So don't worry, we'll see this practically. In template section, we give the metadata related to pod, and also in the specification section, we use the container information. All this we'll see very clearly. I want to, so replication control is all about load balancing. When in Docker Swarm, we have concept of service object, Docker service create hyphen replicas. Isn't it, Danuj? We have discussed about service object. Something similar to it.
Replication controller, is it a kind of swarm? Docker
Swarm on in Swarm only we have learned how to in Swarm we have seen on the, how to create a service, right?
Okay.
Docker service create hyphen replicas equal to 3. We have created a number of containers.
Yeah, right.
Using a specific same thing like here also.
Same thing here.
To create a replication controller with how many replicas? 3 replicas of HTTPD. Okay.
Got it.
Let's do that. You will find 4 top level elements as usual.
API version 1.
API version.
Replication.
Metadata specification section. Okay.
Right.
Next. API version should be V1 because if you're creating replication controller, whether it is pod or replication controller, the library should be V1. Next. Metadata. If it is pod, you mention the pod name. If it is replication controller, we mention the replication controller name. I have a habit of creating a replication controller. I want to name it as ending with RC. Okay. So HTTPD-RC is the name of my replication controller. Replication controller name can be anything. I can write it as RC1, RC2, or anything. Isn't it?
Could be.
Next, labels. Labels is any user-defined key value pairs. I'm writing it as author as Sunil. No doubt till here. Clear?
Labels could be more than one.
More than one. Last time so label was 2, right?
2.
Isn't it? How many labels were there? Author Sunil or type equal reverse proxy. 2 labels. 3 labels. A number of labels you can have it.
Got it.
Next. Till this part it is clear.
Right. Perfect clear.
In the specification section, here comes important. You have to mention how many replicas you want. Replicas refers to pods. The replicas is a keyword. You have to mention replicas as 3.
3.
Okay, that is in the specification section. We should write replicas. How many replicas you want? First point. In the template section, you have to mention the name of the pod. Okay, this is a template section. Okay. You have to mention the name of the pod. Finally, if a pod should be there, you have to name a pod. What is the name of the pod? I'm writing it as HTTP pod. This label refers to labels for the pod.
Right.
This label is labels to the replication controller.
Got it.
Labels for, you can have labels for the replication controller, you can have labels to the pod. These labels refers to labels to the pod. Other I'm writing it as Sunil.
And metadata is left blank.
Which one?
Metadata.
You have to write it in next line.
Okay, got
His
it.
label is blank. No, we are
Right,
writing
right.
it in
No,
next
no,
line.
next
Okay.
line, got it. So metadata, okay, got it. Name.
Okay, name. Next. So what is this? Name of the pod.
Name of the pod.
Inside the pod, what you'll have? Container.
Container.
In the specification section,
spec-
this is some specification
container.
section for the pod.
Got it.
This specification is for the replication controller. This specification is for the pod.
Pod.
Okay. What is the container name?
My HTTPD.
My HTTPD. What is the image?
Right.
HTTPD is the name of the image. This is a Docker Hub image. Okay.
Yeah, got it.
Default port is 80. You have mentioned that. Can we have
Yeah,
ports?
port
And I have mapped to 8080 port. Okay. Like this, you have to create a replication controller. So replication control will have a special section called as specification section. In the specification section, using a keyword replicas, you have to mention how many replicas you want. In the template section, you will provide the pod details and the corresponding specification details of that particular pod. Clear?
Got it. Sunil, container port. So this port 80.
Container port is referred to default port of the HTTPD.
Okay, so this will get it from the document from the Docker Hub image.
Yes.
Documentation.
Tomcat
here,
8080, something like that.
Here, host port, I can make it
mapping.
Mapping.
Any 4-digit number.
Got it. Understood. Perfectly understood, Sunil.
Let's do this. I'm waiting for the pod to get created. Let's test my luck. Okay, it's not getting created. Let's experience it. Let's continue.
Got it.
Creating, not via editor, you do it using cat command this time.
The ending line is optional.
Control D to come out of that. It's optional.
The last 3 dots are optional.
Yes, yes.
Okay.
You can see the second file, Anuj, replication-control.yaml file. Next thing what you have to do, run the definition file.
Run the definition file.
Let's delete all the pods. We'll have a discussion about why it is not creating a pod. Meanwhile, let's continue. Okay, let's delete all the pods because we have limited infrastructure. That's my Kubernetes needs a lot of hardware.
Got it.
See, just deleting a pod, how many seconds it is taking? It's not fast. Even this, these are nodes which are 4 GB memory and 2 CPUs. Okay, but still you are experiencing some performance issues. Okay, now
so it's heavy. It's heavy.
Heavy. I think now there will be no pods because we have already deleted the pods.
Deleted the pods.
Yes.
Right.
And then if now once the port mapping is done, if you want to access this particular HTTPD from my personal laptop, external network, Anuj, I need to open the 8080 port.
Right.
Isn't it? In AWS, we do it using security groups, isn't it?
Right.
Whereas here we do it using commands. So Google Cloud Compute Firewall rules. You have to mention any rule number, allow TCP:8080. You need to allow the ports. I don't need to run this because I already have executed this particular ports are already open. Now I am directly creating a replication controller object. Replication controller has been created. Okay. Now, what is the command to see list of pods?
kubectl get pods.
How to see list of replication controllers?
kubectl get
replication
controller.
Okay, but get pods. Now that replication controller should have how many pods?
It will be having
3 because replicas you mentioned it as 3.
Mentioned 3, right?
So it should create 3 pods. Now if I search for get pods, the 3 pods are running. Okay,
one on each.
3 pods are running. So these 3 pods are on running on which nodes, you know that wide output.
Yep.
Okay. You can see 3 pods are running. I think each pod is running on
Each
individual node. So load is equally distributed. Okay. Now, from my personal laptop, can I access this particular HTTP pod? Okay. Okay. So in such case, I should take the public IP of the node.
Right.
Here you're getting the node name.
Node name.
There's no public, the IP address is not visible. Okay. So you have to use get nodes wide output. Understanding, Anuj?
Right. I got it.
Get pods will give you pods details. Get nodes wide output will give you node details.
Node details.
And the corresponding IPs.
IPs.
External IP is nothing but the public IP. Okay. So I can take any public IP because pod is running on all the 3 nodes, isn't it? Okay.
Got it.
So I can take any public IP. Which one shall I take? So let's take the first one, or let's take the middle one.
Any.
So I'm taking this middle one, .75. Dot. What is the port number?
8080.
It works.
It
Okay.
works.
This is the default page of HTTPD. So you are not only created the pod, now you're able to access externally from the pod. More than that, what you have done, you have not created individual pods. You have created a replication controller. Replication controller, finally, the pods are running on 3 nodes. Finally, you have handled load balancing, Anuj.
Right.
Okay. Okay. Now I think if you delete the pod, the new pod gets created here. Okay.
Can we do it?
Yes, I think so. I think it works for the high level objects. Get pods. We should get 3 pods. Let's take a note of a particular pod. I'm taking the first pod. Okay. Delete pods followed to the pod name. Anuj.
Right.
So I'm deleting specific pod. Okay. Now, as per the definition file, we should have 3 pods.
3 pods.
The current status is not equal to the desired state. The controller manager should trigger, and it should finally again how should have how many pods? 3 pods. See, 1 pod is 16 seconds only. This is newly created pod. Okay. Okay. So are you understanding? So it
Sunil,
makes...
in the first example, we in the definition file we have not mentioned any number. Will it?
Which one?
I was thinking that we have created a service. This is similar as a service. We created a service.
This is something similar to service in the Docker's
service form. In the Docker's form, right?
Yes.
So if one is gone, the another
automatically
one is...
because you have created replicas 3, right? At any point of time, 3 will be
there.
If you remove 3, again 3 create. 3 will
correct. So in the first example,
it is not achieving probably at pod level, individual pod level, the desired state is not maintained probably.
Could be
because
yes.
It is the smallest level.
Yes.
Now, replication set. Replication set. Okay. So total, how many objects we have experienced, Anuj? 2 objects. One is pod. The other one is replication controller. Agree?
Okay. So if you want to finish it we have to remove the definition file.
Now, if you don't want that pod, now you recreated, Anuj. We have practically seen it, right?
Right.
You don't want it to be recreated. What you have to do, remove the file.
Remove the file.
Then it will be not created. Fine. And the existing pods will also be terminated automatically.
Sunil, one more question. So, for example, if a service is running on 3 nodes, 3 pods.
3.
Right?
No. 3 pods are running on. Don't use service. There is no term called service. Okay.
Okay.
So 3 pods are running on 3 nodes. Load is equal.
3 nodes. Load is equally distributed. So, for example, if it is being some data is there on one pod, some data is another, some data on third one.
I understand.
The moment one pod goes off, restart or anything happens,
automatically that pod will be shifted to the existing nodes, other nodes. Okay. Handling failure scenarios. Okay, automatically it happens. Okay.
So data will be shifted with data.
I
right?
have shown you with data. There's no loss of data. We have seen that use case, Anuj, in Docker's form, isn't it? By stopping a particular container or something like that. By stopping a particular worker machine. I have shown you, isn't it, Anuj?
Right,
All the
right.
pods which are there in the work permission shifted. But here I cannot show you because because it is given as form of a service, right?
Service, right.
Cluster is connect, so that's how it handles by itself automatically.
But there is no data loss.
No data loss at all. Okay. Yes, Azam.
Sir, can we create replica of existing pod?
Yeah, that is replication set. That means,
Yes, sir.
Pakar,
Yes.
existing independent pod is there. You
Yes.
want 3 containers. You want your you want finally 3 containers. Okay, you don't want to create 3 containers. Already one existing pod is running. So you want to take that pod as part of replication controller for load balancing, and you want to create remaining 2 pods. Isn't it, Azam?
Yes, yes.
That can be handled using replication set. Important interview question. What is the difference between replication controller and replication set? So we'll be seeing that soon now.
So
Azam,
one
okay.
more dot I have.
Okay.
You are telling that suppose we need to delete pods, so we have to delete YAML file, right?
Hmm.
So where I have to delete that YAML file? YAML file is
File name, right? Because
File.
let's say, for example, replication controller shall be deleted. We have one file, Azam, isn't it?
So where is that file?
This is one. LS will show you list of all the files.
This is like Docker daemon, right? This is a client. We used to, practice Docker
Yes,
in
yes.
Git bash.
Right, you are right. And in Docker, Azam, we have connected to which machine? Manager machine.
Manager machine.
Okay.
Yeah. So
Here-
this YAML
here
file
now-
is in
Yeah, in
this YAML file is in master machine.
master
right?
machine. Yes, you are right. Okay.
Okay, sir.
Yes,
okay.
everything
So
handled
if-
from the master.
So if we delete
YAML file
anything we get, any changes in that YAML file, that will be replicated.
reflecting. Yes, it will be reflected on the nodes.
Right? Okay, thank you.
Okay, Azam. Now you have that file, right? Replication -controller.yaml file. Okay. So let's remove that file, Azam.
Mhm.
Okay. Look at this, Azam. Delete -f replication controller.yaml file. File deleted, Azam. LS, I think the file will not be available now. Definitely.
Yes.
Where is this? Did we delete it? We have deleted, right? Replication -controller. Okay, now if you see, sorry.
No, it's not deleted.
Pods are removed
Removed.
because the replication controller object is deleted. Okay. Okay, if you want to remove from the file RM. Okay.
But Sunil,
Remove
we have
file name.
not we have not removed this file. So will it get automatically created again?
No. The complete replication object is removed. Okay?
Object.
I think it will not be created. Okay. If you want to remove it from the file, you have to remove it by using RM command. Okay.
Mhm.
Now let's move on to replication set, which Azam is referring to. Pod is the smallest Kubernetes object which we have worked on. The next level object what we have learned is replication controller. Next we are learning replication set. Replication set is similar to replication controller. In replication set, we have an additional field in the specification called a selector field. The only new thing what you find here is selector field. Azam, by looking at a selector field, you can easily understand it selects the existing independent object.
We just
independent
need
pod.
to mention the pod name.
That's
Right?
not pod name. You have to mention the labels. Okay.
Label.
So this selector uses the child element called match labels. Okay, which will search for the standalone pods based on the labels and add them to the cluster. Okay. That means let's look at this. Create a replication set with how many replicas, Azam? 4 Tomcat replicas for performing scaling. In real time, replication sets are used. Replication controllers are not used. Replication sets are only used. Okay. So let's go ahead with creating a replication set. Anuj, API refers to app/v1 for replication
App/v1.
for replication set. Kind refers to what kind of object you are creating. Are you creating pod? Are you creating replication
Right,
controller? Are you
set.
creating replication set? Metadata, if you're creating a
Metadata.
replication set, you want to provide a name to the replication set. I am writing it as Tomcat-RS. Okay.
Right.
Labels are labels to the replication set. Okay. These
Okay.
are the labels for the replication set. Type equal to web server, author equal to Sunil. I can write anything. Okay.
Right. Replicas 4.
Specification replicas 4. That means 4 pods will be created.
4 pods.
Next. Next. Selector field is something new. Finally, this replication set should have, under this replication set, Anuj, we should have 4 pods.
4 pods.
Assuming there is one pod already created in the cluster, which is not part of replication set. Independently, there is one pod running in the cluster. Okay. That pod, in that pod, labels will be there. If that label is type web server,
Okay.
that pod labels will be there. If that pod label is web server, selector field selects and matches as that pod type is also web server. That pod is also pulled as part of replication set. So only remaining 3 containers will be, 3 pods will be created.
Okay. So it is
I
just
understand.
like there are orphan pods.
Orphan
Which
pods.
they are running. They may not be useful. How could
Useless.
identify? Useless. We can just pull it with a label type.
Yes, using the selector field, the replication set object
Got it.
selects the orphan pods
Got it.
or standalone pods and
Right.
uses them as part of a replication set. Okay.
But they will only pulled if they are not being used. If they are being used, they will not be pulled.
It's not like used or not used. So that's the reason we should be careful in defining the labels. Okay. You should be careful in defining the labels. You can, all that labels should match. One pod can have 1 label, 2 labels, isn't it, Anuj? 3 labels, and number of labels. Every
Right.
label should match. It's AND
Okay.
condition, not OR condition.
Got it. Got it.
Okay. So to filter it to maximum extent. Okay.
Perfect. So if that means if there is a one pod running which has one type is a web server and another level is there, that will not be pulled because
Will not be pulled. Only exactly matching should be the AND condition. Okay.
Got it.
In the template, this is about pod metadata. This is the name of the pod. This is labeled to the pod. Specification container. You need to think when in the specification container, specification, you need to think from the container point of view. This is name of the container. This is name of the image.
Right.
Tomcat default port 8080. Mapping it to
9090.
Okay.
So
All
Sunil,
this
that means it is not
hands-on.
if label matches and that pod is being used for some maybe some image or anything else, even then that will be pulled, right?
That is the reason
Label
we should
matches.
that is the reason we should make sure the labels are always unique. The more number of labels, the more less chances of filtering. Okay. You have to have your unique labels. Okay.
Right. If doesn't match, it will create 4. If it matches 1 or 2, it will create the remaining one.
Yes. Generally, standalone parts are very rare because finally we use orchestration for load balancing, scaling, and all this. Okay. Independent parts will not be there. Everything will be under replication set only because you want to have the advantages of orchestration. Okay.
Got it.
Advantages of orchestration you cannot achieve by using orphan pods, isn't it, Anuj? Okay.
Right.
To start, to make ourselves comfortable, we have started with pod, but we'll never start with pod. We always create replication center if you want to perform load balancing. If you want to perform rolling update, there's one more object. Okay. We don't start with creating the pod. As we have started creating the pod, we are getting those choices. But independent pod, where exactly it is used? Not used at all. Okay.
Okay. Got it.
JS3.
Sunil, Docker seems to be very easy and Kubernetes is little complex than Docker.
Let's do this. So
Control D.
create -f and the file name is replication. Before that, I think the current status of the code pods. I think no pods. No pods. Okay.
Right.
Now, the moment I run this replication set, how many pods we should have?
3. 3 mentioned. Oh, 4. I'm sorry.
4. Mention it as 4. Okay. The replication set tomcat-rs has been created. Now kubectl get pods. How many pods? 4 pods.
4 pods.
Right. Still in the process of creation. It will take some time. Okay. So 4 pods. Okay. Get replication set. We'll show you list of replication sets. How many replication sets we have? Only one replication set.
one
What is the
replication
name of the replication set? Tomcat-rs. Okay. The replication set desired state you have mentioned as 4. The current state is also 4. 3 are ready. 1 is still in the pending. It will also get ready soon. Okay. So like this, you can see get replication set, get pods, get service objects. All this you can see by you get nodes. These are all common commands.
One node would be having two pods running. I hope.
Yes,
you have 4
right.
created.
Yes. Definitely one pod will take the 2 load. Okay. Now I want to perform scaling. Let's move on to next advantage. I want to perform scaling. Scaling is nothing but increasing the number of pods. Right now replication set is having how many pods? 4 pods. I want to perform scaling from 4 pods to 6 pods. Okay.
Sunil, here in all examples, we assume that one pod contains one container. I hope we will be
generally there are cases, but generally better to have one pod, one container. If you want to have multiple containers, better to create multiple pods. Standalone, good practice.
But that is not preferred.
Make any hindrance. Does not make any hindrance. Okay, isolate it from the pods point of view and deal with pods.
Got it.
Vasant.
Yeah, Sunil. What is the difference between replication set and replication controller? Yeah.
Okay. In your cluster, okay.
Yep.
In your cluster, you have created a replication set. Sorry, replication set. Okay, you have created a replication set. Vasant, you have created a replication set. In the replication set, you have mentioned number of replicas as 4.
Yep.
You can see here. In the replication set, you have mentioned number of replicas as 4.
Yeah.
So finally, how many pods should be there inside the replication set?
4 pods.
4 pods. Finally, it should have 4 pods. Agree?
Yeah.
Okay. Assuming there is one pod, which is standalone pod, which is outside the replication set. We have created one independent pod. Okay. In the replication set, you have mentioned selector field. Match labels. If that standalone pod label is type web server, if this standalone pod label is type web server, if that standalone pod label is type web server, Vasant, then that particular pod will be pulled into the replication set. Okay. Got it? So finally it will again only create 3 because finally you want 4, right? Are you understanding?
Yes.
So orphan pods or standalone pods can be used in the replication set. Okay. Whereas in replication controller, it cannot be used. Am I clear?
Yeah, but only that is the difference. Like only for that we have 2 different things. Like
that's the difference. But replication control is pretty outdated. Everyone now using replication set. Okay.
Oh, okay. Okay, got you. Thank you. Yeah.
Jayasri.
Accidentally I raised the hand.
Okay, Jayasri. Yes, Balaji.
Yeah, so like here, a type, right? Main thing here changes from the replication and replication set.
The replication
controller and replication set. So if we have like 2 web server type means then it will create only 2.
It will create only 2. The remaining 2 will be pulled into the replication set.
Like we can create multiple sets, like one set for web server, one set for application server.
You can do that.
Only this type of type should be entered into that.
Yes,
right?
You are right. Yeah, you are right. Okay.
Yeah.
Okay. Next. Now, Balaji, I want to now how many pods are running? You can see Balaji, there's 4 pods which are running, isn't it? Okay. I want to scale up. Okay. So I want to perform scaling. Okay, from 4 pods, I want to move to 6 pods. I want to increase to 6 pods. Option 1, 2 ways you can do that. Option 1, open the definition file, make changes in the replicas you have mentioned as 4, change it to 6. Okay, change the definition file. Okay, so let's do that. So I open the file. Open the file. I go to insert mode. Okay, Anush, replicas is 4. I'm changing to
6.
I'm changing. So I'm changing the definition file. Agree?
Right.
Once I change the definition file, escape :WQ to save and quit. Okay. Yes. Now kubectl create. If you're creating a new replication set, we are not creating a replication set. You want to change that. You have to. You want to update your replication set with the new definition file. Replace. Agree?
Right.
Replace the existing object as per the dimension file mentioned in the replication-set.yaml file. Okay.
It is just like rerunning it.
Rerunning it.
Got it. And we have used word replace just because we have modified it.
Yeah, because the replication set is already there. Okay.
Now
Got
it.
Now you.
So that means the moment we create a definition file, it gets loaded to somewhere else as well.
Yes.
And right. we want it's just like a Git. We have to from the local memory to the main. Local repository. We are replacing it to the controller. Okay.
Terminal is something like an OS level. Okay.
OS level. Upload it.
And yeah, so kubectl get pods.
Got it. 4. So 6.
Not 4. 6 is there now.
6,
okay.
Got it.
So we are increasing the number of replicas. Okay. So this is one way. Okay. Option 2. This is a command. You don't want to change the definition file. Definite file remains as it is. You can do that. kubectl scale. Kubectl create. To create kubectl replace to replace the definition file, kubectl scale --- replicas. Now I want to scale down to 2, and I'm referring to this particular replication object present in this particular file. Okay.
Got it.
Now I'm scaling down. So number of pods will scale down to 2. So using the command. Okay. Now kubectl get pods. Now it's terminating. One is terminating. Finally, you end up with 2 pods only. Okay. So like this, you can perform scaling. You can scale the pods.
But this is a manual one. I hope we'll be seeing in later examples the automatic one.
How did we handle the scaling in the Swarm?
That was automatic.
How?
Load balancer.
Load balancer is distributing the containers to the nodes. We have done it using command.
Command.
Okay.
Got it. Sunil, one more thing. Can we connect to the 1 minute? There is no concept of logging in pod, right? There is a concept of logging in container.
Logging into pod in the sense we have using HTTP pod, right? It works. You got a message in the web browser.
So so that means pod deal with container.
Yes, the moment you connect to pod, you are connected to container. That's it. Now
container.
Remember equation pod equal to container. Okay,
when you're learning Kubernetes. Got it. Perfect.
Sunil, I have one question here.
Yes,
like the scaling up and scaling down, does it not happen based on the some condition like CPU utilization? And
You are comparing with auto scaling feature. Okay.
Yeah.
Okay. Why the point is why we are not getting this doubt in Swarm. Swarm also it should have happened automatically, isn't it? Yeah. Now the point is, I have a question, Vasant.
Yeah.
Forget about Kubernetes. I'm talking about Docker.
Yeah.
Container is ephemeral. It's temporary. Agree? Infrastructure, whenever a team needs it, we are providing the infrastructure. They are using it. Fine.
Yeah.
When it is temporary, why are we worried about load balancer? Let's say development team needs Vasant.
Yep.
Let's say development.
No, actually, I heard that like Facebook and other, they use these containerization on their production, not only on the developer.
What scenarios it is used?
In even Google use Kubernetes.
In what scenarios? Okay.
Sunil, take an example.
I have shown you, Anuj, day on the course form. I have shown you MySQL online. Do you remember?
Yeah.
MySQL online. Learn MySQL online. You don't need to install MySQL. If we want to learn MySQL, we are connecting to the MySQL pod.
Yep.
Okay. That container, that applications can run it on Kubernetes also. You can also finally you end up with a pod, or it's finally a container.
Yeah, in that
Okay?
case only.
So that's a
Sunil,
production environment. So in such cases,
yeah.
if there are huge traffic getting to that particular web application, when there are too many environments opening up, Vasant Kumar, isn't it?
Yes.
Okay, when too many environments are opening up, okay,
Yeah.
clear. The front end environment, wherever the application is built, Vasant, the front end environment where the application is built, it can be built on Node.js or AngularJS or JavaScript application, isn't it?
Yes.
So there we write this Kubernetes command so that it can triggers automatically. Okay.
So at the end of the day, it should be always based on the actual and the desired number only.
Yes,
You scale between those numbers only.
You are
right?
right. You are right.
Okay, got
Okay.
it. Yeah. Yeah.
Either you can increase the pods.
Yeah.
You have to increase the pods finally, or use handle it using the AWS feature called auto scaling. Okay.
Auto scale.
Okay.
Where you can leverage your in hardware. Okay. So two
Sure,
levels
sure,
you can handle it.
Yeah, sure, got it.
Okay. Yeah, let's move.
Now, Sunil, I got my answer. Reason the infrastructure we will be dealing with AWS only.
Yes.
Because I was thinking that if there is a Netflix, there is a Amazon sale going on, and the sale is for 2 days, weekend sale. There could be a 1 lakh subscriber, 1 lakh transaction. There could be 5 lakh or 10 lakh, 5 lakh or 10 lakh transaction. So background, there should be, if everything is running on container. So a background, there should be a feature where it should have 1,000 containers or 1 lakh containers. So we'll be placing it dealing with AWS, attach it with AWS.
You're right.
That's why I joined 2 batches.
Now look at this. So we have discussed how many objects? 3 objects. One is pod, the smallest object. Replication controller, pretty outdated. Replication set is latest version of replication controller where you have selector field. More than that, we have learned how to perform scaling of pods and scale down. Okay, next. This is one small example. Just to create, this is an independent pod, Anuj. Okay, so kind is pod. Look at the first whenever you look at a definition file, you have to first figure out what kind of object this definition file referring to, Anuj. Okay, so we are creating a pod. This example just to show you. Okay, in the specification section of the pod, we always think about containers, isn't it? The name of the image is the name of the container is my progress, my Postgres, and the image is Postgres, and the Postgres image should have environment variables. In case,
right.
So don't think that if the image needs environment variables, whether it is inside the pod or outside the pod, doesn't matter, isn't it? You have to provide the environment variables.
And
so
that is a container concept.
Container concept. So you have used. I just want to show you this example. How can we have environment variables within the container of a specific pod? Okay.
Got it.
So look at this.
So Sunil, that means either it is a Docker or it is a Kubernetes. If we want to have auto scaling, we need to be dependent upon approach. We need to depend upon the cloud platform.
That is the first preference.
Got it.
First preference.
Because Docker Swarm also meet the required and desired state.
Pod-definition 2.yaml file.
Sometimes attendees also give you tough times. They ask so many questions. But actually it increases the trainer's knowledge as well.
Yeah.
Sometimes any question is not expected, but somebody asks.
Many times after the session I spend some time thinking back the questions asked by the participants, and then it helps me in upgrading myself also. Okay. That happens.
And that's what we do. We ask our juniors, please don't bother to call us, ask questions. Sometimes we get troubled, but it increases the knowledge.
Create a -m definition. I'm creating a pod definition file, so the pod gets created. The new thing what I want to show in this example is how to see list of all the pods. We already know it.
Kubectl get pods, yes.
Okay, so I think we have 2 pods. We have scaled down to 2 pods. This is Tomcat replication set, and this is the Postgres pod which I just now created. Fine. Next. To get the list of pods along with the IP addresses, we know that.
Yeah, wide.
That is known along with the IP addresses of the nodes. Okay, this is nothing new. We already know this. Next point. If every pod will have an IP address, isn't it? As per the architecture, it is a proxy server which proxy component, which will kube proxy is a component which will assign the IP addresses to the pod. If you want to get more information, so pod is ready, Anuj. This is Postgres pod. You want to know this pod is having. You want to know container behind the pod. What container is running inside the pod? Huh? That container is using what image. If you want to get more information about the pod, we have a command called describe command. kubectl describe pod followed to the pod name.
Got it.
This will provide you more information about the pod. When you want to know the underlying container information, what image it is using, what environment variables it is using behind the particular pod, you have a describe command. Okay.
Got it.
Okay. So this will give you more information about the pod. Now it provides you a lot of information. Look at this. It has scrolled. There's no concept of scrolling up here. Okay. So it has provided more information. So that's the reason you have to use -, pipe less option, so that you get the page-wise information of that particular pod.
Got it.
Now you can scroll. You can see here. This is container ID. This is the
container port ID,
image ID, and the environment variables. Are you able to understand, Anuj? Okay.
Yeah, got it. Yeah, perfect.
So
it's all Docker concept.
So Docker concept, but if you want to know the technical behind the details behind the pod, describe command. I just want to show it. Okay. Next. What is this kind pod? I'm creating a pod. It's a Jenkins pod. Author label. You can see. So I said anything. I can write it. Specification, containers. This is the name of the container. This is the name of the image. Look at this. First time it was feeling difficult, but now you can see easily scrolling down the content, the code. Isn't it?
Yeah, got it. Four values.
Four values. If you spend 2-3 days, within no time you'll review the definition file. Okay. So.
So Sunil, normally this Docker kind of thing, they are not being used for production. They are less trusted one. Is it true?
When compared to Docker, Kubernetes is used.
Kubernetes is used, and they are mostly being used for a temporary infrastructures.
Yeah. So let's go this way. So
mostly the test.
There's nothing special to show this. Okay. Let's do this. I already have opened 8080. In case, in your case, you have to open it manually.
Open it manually, yes. 9090.
So I am running the pod definition file. Get pods wide output. Now you'll get the Jenkins pod perfectly. Know which pod it is running. Jenkins pod is running on a pod. Jenkins pod is running on a node ending with 155Z. So take the public IP of 155Z. You are understanding, Anuj, isn't it?
Yeah, got it.
So just referring to that particular pod. 155Z is this one, the first node. Take the public IP 138.
So one single file run will create a complete CI/CD environment. App server, DB server, everything. Jenkins.
See, starting Jenkins. Okay, it will take some time. So we already have seen it. The same way we have access HTTP Anuj. Okay, nothing new. Okay.
Sunil, can we? So whenever I want to connect to a particular pod, I hope maybe cover in the next class. If we create just like a Unix box, you can say
one minute. Yeah, tell me.
Yeah, if you want to connect to a particular pod and install some software manually, sometimes there is a very special requirement that install this version please for this one. We can do it through the same console, right?
Whatever the software you want to install it, you first install it in customized containers. Okay, create your own container. Let's say you want to install one package inside Ubuntu. Okay, get the standalone image. Okay, create customized image, install some software in that particular image, upload that image into Docker Hub. Okay. And use your pod using the customized image name.
Oh, got
that
it.
application will be available automatically inside the pod.
But so is there not a recommended way to just create it and connect it to the pod and get it installed?
Like interactive terminal you are experiencing, isn't it?
Yeah, exactly.
Okay.
You just enter in the just like you are entering in the container, right? The detach mode and the interactive mode.
Okay. Now I am answering your question. Pyzia.io. Anuj, I am an end user.
Got it.
Okay. I got a MySQL environment. Okay.
Right.
So can I say this is container?
Yes, it is.
Yes, it is. If Pyza is using Docker Swarm. If Pyza using Kubernetes, then it is called as pod.
Pod. Right.
Okay. Right.
Got it.
Either it is pod or a container orchestration tool finally. Okay. Anything from end user point of view, end user will just want to. Okay.
Right.
Will be using the environment.
Environment, right?
Okay.
The image. Right.
Do you think end users will connect to the back end of this particular environment and he creates some environment variables or something like that? No.
No.
Isn't it? That means from end user perspective, he will just use the environment which is provided in the application. Okay. So that means, do you think I want to continue to interactive terminal behind this particular pod? Okay. No. And then I need to create any files inside this particular information. Do you think that is possible actually in the real time? No. Real time is from only the environment usage point of view. Okay. So your question about entering into the pod in live will not happen most of the cases. Okay. Are you understanding? Think from the end user point of view. Have you any time seen an end user making configurations inside the environment when configuration is provided as a sandbox? No. If that is the case, he will do it by himself, isn't it? When he wants infrastructure on demand, the next second he'll start using the infrastructure. He'll not configure infrastructure. Okay.
Yes.
So we already configured the whatever the end application point of view, Anuj. Okay, and we save this in the Docker Hub. Okay, and then we provide this container, and this particular container can be integrated with the applications and then provided in the live. This is live, right, Anuj?
Right, they're live.
Live. So here comes the scaling and all those stuff. Okay.
So that means we create a container first, we install whatever we want to, and then upload it.
This is MySQL, so definitely there will be an operating system on top of it. MySQL is installed. Agree?
Yeah, right. Yes, MySQL is
installed. What you have asked. Okay, and that is available in the hub. Using that, you are creating a pod, and that pod, how that pod will be applicable to the application, that you have to handle at Node.js application level point of view. Okay.
Okay, but is it possible to interact with, just like in a Docker, we were entering in an interactive way in a container?
Yes.
Can we interact?
This is what you are interacting, right? You are interacting here. That's what you are talking about. Are we interacting? Anuj?
Yes, we are.
This is interaction. Yes. Okay, yeah, it is possibility. You handle
to my cannot modify.
You cannot modify.
Okay. You cannot
create tables. You can insert rows.
So
okay, if I want change the database name or something like that.
If I want a specific version or modify anything, meet any peculiar requirement by a customer, this cannot be done. We have to depend upon the service, or we need to request the service provider. We need this. Please provide this.
Yes. Okay.
Got it.
Sir, I have a doubt regarding background process of when we scale pods. So first we put YML file to API server, right? Then it Firstly,
Okay, okay. You're talking about the
background process.
architecture.
Yeah. So it goes to API server, then
Okay.
it goes to API scheduler. I'm talking about
scheduler.
when we scale
Yes.
up
Yeah,
or
yeah.
scale down.
Yeah.
Okay. So it check the current state, actual state, and desired state.
Yes.
So where exactly that YML file is stored in etcd folder?
No,
In
no.
etcd?
Yeah, your side control etcd. Okay.
In etcd.
etcd is a component which will store the complete information cluster. So your YAML files are stored in etcd. But at the same time, Vakar, you cannot connect to etcd or something like that. It's an internal component. Okay.
Yes, yes, yes.
Okay. Finally, the data will be stored here. That means your files are also stored in etcd. Okay.
So controller will
and controller will refer to etcd to make sure that the current state, because the desired state is available in etcd, because that's a cluster store. Okay. And controller makes sure that the desired, it identifies the desired state using etcd.
Okay. Means etcd is store current state, right?
Exactly, you're right.
Okay.
Okay, so today we have discussed about all these components. We have learned about the load balancing and scaling. The next thing what we have to learn is performing rolling updates, and I want to discuss about service objects, which are very, very important. So we'll be discussing that in tomorrow's session. There are two more objects to be discussed. One is service object. The other one is performing rolling updates. So we will see that in tomorrow's class. Probably tomorrow may be the final class, because that will be completing most of the objects related to Kubernetes. Okay. Thank you all, and see you tomorrow. Bye very much.